All right, so this is section 2.4, and so let's look at number 4 first. It says, in your own words, explain in detail why it's the case that two fractions have the same numerator. So we'll say like 7 and 7. And they have different denominators. So we'll say maybe 8 and, I don't know, we could do 42. Or we could do, if you don't want it to simplify, I could make it, say, 8, something like that. Doesn't matter. All right. And it says that the fraction with a smaller denominator is bigger. So if I have the same numerator, why is it that the fraction that has a smaller denominator is greater? All right, so let's think about this. Remember, your denominator is your unit. So if I have a smaller denominator, what that means is my, say, pizza is cut into less cuts, so I have bigger slices. Where if I have the same size pizza over here and I have a bigger denominator, that means that this thing has been cut a lot. And so this bottom, the denominator is telling me, and again, I can't do 48 pieces, but pretend that I have cut this into 48 little slices. Where here it's telling me that I've cut it into just 8 slices. So if you cut the pizza less times, here I have bigger slices. And over here I have smaller slices. So here I have a bigger unit. Here I have a littler unit. But I have the same number of pieces. So having the same number of large pieces as the same number of tiny pieces, obviously having the bigger slices is going to be more. So having 7 big slices, because again, a smaller denominator means I have bigger pieces, is always going to be bigger than 7 tiny things, tiny slices. So, and again, even if this is a 9, like 7 8s and 7 9s, which isn't a huge issue, but if this is cut into 8s, these are slightly bigger. This has been cut more, these are slightly littler, and I have the same number. So 7 big things versus 7 slightly smaller things. Again, this one's going to be bigger. All right, let's look at 8. All right, and in question 8, it says, without using a calculator, order these from, let's see, smallest to largest. All right, so we have all these. We have some decimals. We have some fractions. We have some negative numbers. Sorry, I was eating chocolate, so that is my chocolate smear. Here, there's my snack. Some dark chocolate with some nuts, I guess. I guess it's my dessert. It's not exactly a snack because there's chocolate involved. Okay, so again, remember in a number line, here's 0. As numbers get more negative, they get smaller. As numbers get more positive, they get bigger. So I'm going to look at my negative numbers to begin with. And again, if you think of money, this is like owing owing $1.10. This is like owing 98 cents. So the more debt, again, if you need to put a 0 to see that, that's like owing $1.10. This is like owing 98 cents. All right, so I kind of got those off my list. And then, oh, I have another one. Sorry, I owe $1. So that's going to be in between those guys. Missed that. So I owe 98 cents. Owing $1 would be owing even more money. Owing $1.10 would be owing even more. So I got those. So then I guess I have 1, 2, 3. Okay, I have 3 more. So then I have to look at these guys. You could divide this and realize that this is 1 1/10, which is same as 1.1. And this one is 9/8, which is 1 1/8. Okay, and so we kind of need to compare those. And again, you can't use a calculator or anything like that. So 1 2/10, again, I could write it as 1 2/10. And here I have 1 1/8. Okay, these all are in the 1 range. Again, these have been cut into 10 pieces, right? This has been cut into 8. And actually, I could simplify this into 1 1/5. All right, so then I have one whole thing and I have one little slice extra for all of these because 2/10 reduced to 1/5. So I have one of these. So let's go back to this idea of the denominator. All right, so this one has been cut into bigger slices because there's only 5. So these are bigger. So 1 1/5 is bigger, which is the same as 1.2. So that's my 1 1/5. These guys have been cut more than into 5 pieces, but not as much as 10. So 1 1/8 is going to be next, which again, I guess the original I should write is 9/8. That's my 1 1/8. And then my 11/10, those guys have been cut into 10ths, and I have 1 piece. So again, converting these into mixed numbers with a fraction, I have the denominator or numerator of 1 on all these. So denominator has hardly been cut, big pieces. Cut a little bit more, kind of medium. Cut a lot, that's the smallest. All right, I hope that helps on that one. Let's see, that was what, number 8? Okay, so now let's look at what's next, 11. All right, so on 11, you can kind of see through there a little bit. Does that help? Maybe. All right, so let's look at number 11. It says, come up with 2 different fractions between 2/5 and 3/5. And a lot of times kids will say there are no fractions between there. So if you get a common denominator, and again, you could go with whatever you want, but if you want more options, I'm going to scale these both by 10. So I get 20 out of 50 and 30 out of 50. And so then I have tons of fractions in there. So I could do 21/50, 22/50, I could do 29/50, anything in between there. If you want even more options, maybe multiply them both by 100. So then you get 200 out of 500, 300 out of 500. And so then, because you've cut them into tinier spots, you have more little fractions in between. So you could do like 201 over 500, or you could do 299 out of 500. So lots of fractions in between there. So kind of up to you what you want to do. You could even do 15, you know, and do multiply by 3 and 3, 3 and 3. Do it that way. All right, let's look at number 12. Oh, and it says plot. Ooh, sorry about that. We got to plot all 4 fractions on the number line. All right, I guess I don't want to do those. So sorry. We're going to go back. Let's do 15s times 3 times 3 times 3 times 3. So that would be what? 6/15, 9/15. Because we want these all to be on the same number line. So that poses a problem. All right, so here's 0. So I have 1, 2, 3, 4, 5. So 6/15 would be there. 7/15, 8/15, 9/15 would be there. And again, remember that's really simplified would be what? 2/5 and 3/5. But you can see that these other 2 are right in between there. So 7/15 would be here. And then 8/15 would be there. And I could get out to, you know, 10, 11, 12, 13, 14, 15/15 would be my 1. I want those for my big tick. So since they wanted us to plot them on the same graph, these were not good choices. Okay, math teachers don't read directions. So times 3 times 3 times 3 times 3 to scale them both up to 15. And then I can plot them all on one graph and get it done so that I can see them and I can see all 4 plots on the same graph. All right, reading the directions is important. All right, let's look at number 12. So let me find a piece of paper here. All right, so number 12 says what? So number 12 says, given 2 different methods for solving the following problem, find different fractions in between 3/5 and 2/3. All right, so 3/5 and 2/3. I could get a common denominator again, so 15. So times 3, that would be 9/15, times 5 is 10/15, and that doesn't really help me out a lot. So how about I scale that again by 2 and 2. So 18 out of 30, and then what is that? 20 out of 30, and then I could get, say, 19/30. So one is I could get a common denominator that spreads out the units enough that I could find something in between. And again, if I wanted to multiply, you know, by, say, 10 again, like 180 and 200 and 300, you know, then there's more possibilities. All right, the other option would be to convert them both into decimals. So one is to get a common denominator where you can see fractions in the middle. The other one is 3/5. If I scale it by 2, is 6/10. So I should be able to write that as a decimal without using a calculator. So scale it by 2, I get 6/10, which is the definition of 6 in the tens position. And 2/3, you guys should memorize. 1/3 is 0.3 repeating. 2/3 is 0.6 repeating. So this is 0.66666, goes on forever. So then I know that I could find a decimal between there. So I could do like 0.61 would be in there. 0.6003 would be in between there. 0.64. So I mean, I can just, or 0.645. So I could convert these into decimals and then find a decimal that's in between there. So either one of those is good. All right, and then 17. For some decent paper. So 17 is asking me, so it's talking about 8/11 is greater than 7/10, and he's saying because 8 is bigger than 7 and because 11 is greater than 10. All right, so we got to be a little careful here, because just because a kid gets the right answer does not mean their reasoning is right. Look at the cuts. This one is cut more, so this one over here has smaller pieces. Let's get rid of that reasoning. So this one has smaller pieces because it's cut more, but it has more smaller pieces, but this has less big pieces. That does not always mean that one is greater. More of a small thing does not always mean, is not always going to be greater than less of a big thing. So for example, say I have 800 pennies compared to less of a big thing, 7 $1,000 bills. Okay, so I mean, this is worth, I have a lot of tiny things here and I have less of a lot of big things, but we all know that in this case, like $7,000 bills is going to be way more money. All right, so again, just because you have more of a tiny thing does not mean it's going to exceed less of a big thing. All right, so why don't you pause here and try to think of some other examples on this, and we'll come back and chat about this. Okay, so let's think of another example if you haven't already. So say I have more, so say 111 of, let's see, small things. So maybe I have 111 of really, really small things. So say things that are cut into 30,000 pieces. So they are tiny, tiny, but I have 111 of them. All right. And then over here, maybe I have things that are cut. Let's see, I need what? So here's more of a tiny thing. So less. So say I have 110 of a slightly bigger thing. So say it's bigger. So say, 200 maybe. All right. We definitely know that this is going to be bigger. I mean, this is almost 50%, a little bit more than half. This is not even close. Okay. But again, I have what? I have more, because 111 is more than 110. I have more of a tiny thing. Now, again, sometimes we, choose to get a common denominator. We're trying to use reasoning here. So in this case, it's too close to tell. It's hard to tell. So if you get a common denominator, right, then you could be like, okay, well, the reason this one is bigger is because if you cut them into the same number of pieces, here you have more. But you can tell there's only a difference of 3. And if you cut a pizza into 110 little pieces, is it okay? That 3 is hardly noticeable. I mean, it would be hard to tell. So again, just because you have more of a little thing does not mean it's always going to be bigger than less of a small thing. There's a lot of examples where I could have less of a small thing and that answer's way bigger than having slightly more of a tiny thing. So that's kind of where his reasoning went wrong on that. Again, thinking of a pile of pennies compared to, like, say, just $5 bills, 7 $5 bills, or well, I guess that'd be what, $35? Yeah, so that'd be more too. All right, I think we're going to end there. Good luck, and you guys have a good one, and I'll see you soon.